All right. So, hey, everybody. Hope everybody's doing well. So, we are in week three, the development phase officially, and we are on our 7-week challenge, and we are done with week one and week two. So, just to recap, in week one, we deployed a mobile application called Cable Snap, which is now on the App Store. The second week, we built a product called Layover Genie that I've submitted to the App Store, which is still in review. And I believe by today or at the latest by tomorrow, it should be ready to go. But we showed what exactly was the first review action we had to take. And I showed in the previous video on what I did, how easy it is sometimes to figure out what Apple is asking you to do and get that done. And with that, we are now in week three. And week three, we are building this application called Travel Stops. And for a twist, it's going to be a web application. We are going to attempt that. And so, Travel Stops is this application where, let's say, you and your family are taking a road trip between point A and point B, say between Seattle, Washington, and Portland, Oregon. In fact, me and my family were doing the same thing between Spokane, Washington, and Seattle, Washington, and none of us are very have a very good sense of direction. And the thing is, my wife and kids, and probably your own family, your close ones, whoever they are, might find it an issue to stop at public restrooms. And it might be that public restrooms might be far apart, they may not be optimally placed for your road trip. And all of this put together gave me the idea that, hey, maybe I can build an application which does some sort of a smart planning and figures out what are the optimal places to stop for a restroom break. And they should be clean restrooms, they should be like travel stops and not public restrooms. And this gave me the impetus to start building this application now called Travel Stops. And what Travel Stops is going to do is it doesn't look for every 1 hour or every 1.5 hours exactly the point of time and if there's a rest stop present. That's not how it's going to work. So this project is going to focus a little bit on how the backend algorithms work. So we are going to have this twist every week. Last week we looked a lot into security. This week it's more going to be about how we come up with some sort of a smart planning and then come back to the user with an output. Given that that is our goal this week and we want to, given point A and point B, find a route between them and suggest optimally placed travel stops, we are going to start building that application. And I somehow feel this is an application that a lot of people can actually use as well. And it might have a reasonably good product market fit as well. But that again is not the goal of this channel nor of the challenge. And I just wanted to say that if this is something that fits your cup of tea, then maybe think about how you can just take this application and maybe take it to the next level. And without further ado, let's quickly look at the code. Again, the architecture is going to be very similar. There's going to be a Lambda function with Bedrock, with DynamoDB, with API Gateway, except the front end now is going to be a React front end. And I'm planning to deploy it on AWS Amplify. So that is going to be the whole picture of what we are going to be using. And the key behind this whole function is going to be the Lambda function. Now, I do want to mention that I am thinking of actually building a Kubernetes based solution using managed EKS service as well in the 7 week challenge. So every week there's one sort of a twist I'm trying to bring in so that it doesn't seem like a very repetitive architecture. However, I still feel that the serverless architecture is the most stable, is probably, I mean, of course, has its downsides like late startup times and things like that, but it still is one of the easiest architecture that is industry grade, enterprise level, and can directly scale easily, become highly available, all of that good stuff. All right. So please stay tuned for other different kinds of architectures we'll use for building other applications. In this application for the Lambda function, we are going to define our Google API key, and then we are going to call a DynamoDB table. And then if you remember, in DynamoDB, all of the float values should be converted to decimals to avoid any kind of precision errors. And so that's what we are doing. And all the dictionary objects, we are going to make sure that DynamoDB has the typecast that needs to be agreed to. And so we are going to fix all the typecasts that match DynamoDB. The next thing is we are going to be using the Google directions and I should make the correction, and places API. Okay. So the places API is the very important API in Google that they provide, that gives you an exact description of the location, gives ratings if it's a business, tells you what are all the facilities available there. And so it's a very powerful API, probably the best on the planet, and we are going to be using that. I should mention that the Places API is not a cheap service. So even while testing and making API calls, be very conscious of the fact that it costs you quite a bit of your pocket money. So if I go in here, just make sure that you understand per API call what is the cost that you might incur. Okay, so anyway, I think you can go in here and actually take a look at the pricing, and be convinced that you can actually pay for it. So here is the URL, and you're going to have the origin destination. The first thing we have to find is the actual route between point A and point B before we find the rest stops. And so we have some exception handling conditions, and then we are going to extract the distance and how much time it's going to take, because of the time is going to define how many rest stops you want to have in between, and the distance defines how long, how far is from point A to the rest stop. And in all of this, I assume 60 miles per hour as being the optimal speed at which the car is running. And so the next thing is we are going to compress Google's output into what's called as polyline. If you're not very familiar with polyline is a compressed. So think about Google every time saying a turn by turn direction from one place to another place. All that is going to be individual lat long points, and so you to store all that data is going to be really high memory, high storage, everything. And so that's why there is what's called as a polyline format, which compresses all this data so that you're not individually storing every single thing. It's going to be one giant string that is going to be stored. All right. And so we are going to take the data and convert it to a polyline format. Now, the heart of this entire application is going to be the smart stop. So this is the main part where we are going to find where the rest stops are. So the thing is, I start with 1.5 hours, meaning first time we are all excited, but for some reason, I think you also feel this, is we want to stop too. It's something that you don't really need breakfast, but you kind of always want to stop for breakfast. And after 1.5 hours, let's say we stop, and then approximately, okay, I should be very clear here. So this is approximately, and then every approximate 2 hours, because if you're going to use just these two values, there may not be a rest stop at all, right? And so in speed, I'm having 60 miles an hour, and then I'm having all the MKS unit systems. So I'm having kilometers per hour and converting to meter per second as being the speed. And then first thing is the first stop is 1.5 hours. And after that, what we're going to do is we are going to plan stops every couple of hours, approximately from that. All right. And that goes in the bedrock, to say the approximate part. All right. And so once we are done with that, all we are going to do is we are going to find the distance, or the mean distance between the all these polyline plots, polyline points. And once we are done with that, we are going to have indices for each of those stop points. We are going to have indices, and those indices along with the plan stop hours is what we are going to return back. All right, so this is really, when I say the algorithm, this is pretty much it. So this is where you might want to think about, your real basic physics on how do you convert speed and time to distance, and the opposite way, and how do you add things. So it's not real extreme math or anything. It's just some basic understanding of distance, speed, time, and all those different things we learn in our first physics class. So once you're done with that, we are going to use the places API, and given lat and long, what we are going to do is you're going to look for gas stations, and these are going to be branded like Pilot, TA, Loves, maybe in Texas it's probably Buc-ee's, and then it aggregates all results across the keyword search. Okay, so the keywords I'm having here are travel stop. Okay, so this is making sure the travel stop is not just loves frying jane pilot and things like that. It could also be something else because it comes under the keyword travel stop. So hopefully that makes sense. We are not hard coding just for three travel stops. All right, and then we are saying that the input is going to be the location, and that we are wanting from the lat long perspective, and the radius is how uh, in what vicinity is it going to be a travel stop. Is it going to be in a radius of 10 kilometers? This is the main travel stop. So that is going to be another part of the parameter of the keyword. And then we are going to look for gas station specifically. It could be something else as well. You could go into rest stops, or much more specific types. And so once we are done with that, we are going to get the results. And here you can see the location is going to be the we have tried making it real time. Okay, so when you're actually driving, it will compute this and tell you as well. So that is possible as well. So we are going to get the name, the lat, the long, the address, the place ID, rating, user rating, and the keyword. Okay? So these are all the different outcomes. Like I said, the places API is a lot more values it sends as results as well, but we are choosing some of these. And out of all of this, we are going to take the best rating and give it a higher score. Anything that is branded like a truck stop or a travel center, because we just said gas station, that also we are having scoring mechanism that it gets a higher score. And those that have more reviews are weighted slightly more. Okay, so that's what I mean by the boost here. Is first thing is I'm going to have the branded name. So in case I'm going to get the rating, and I'm going to give it a boost of 1. And I keep giving more and more boosts for all these three different parameters. So branded stops and stops with more reviews and a higher rating. Okay, so all three of them put together gives a score for each travel stop, and we are going to rate them by the score, sort them from highest to lowest, and we are going to pick the one with the highest score. And then what we are going to do is we are just going to write all of this into the DynamoDB table as well. Everything that came back as an outcome from the places API. And then comes the Lambda handler function. Okay, so the Lambda handler function, what it's mainly going to do is it's going to parse the origin destination, search for the best traveled stops and best stop, and results to the DynamoDB. Okay, so again, after this, it is pretty straightforward. And here in this particular application, I'm really not using Bedrock or any AI service from AWS here, because I just wanted to try something which looks like AI, but is really not anything specifically AI. Right? So you could be smart with other APIs as well, and use them. And so when I say AI, I mean like LLMs. I'm not using LLMs here, but LLMs can make this go to a whole other level, and possibly by the end of this week I might actually end up using LLMs as well. Okay, so hopefully this algorithm made sense. So let's go ahead and do a quick test on the Lambda console. And so I think I've written the JSON somewhere. Yep. And so let's go ahead and put this key value pair. So I'm going to look for Seattle to Portland and see what it comes up with. So let me go ahead and test this. So you can see that this is the initial start. So it takes again a little bit of time, but not that much because there's no LLM that it goes through. So between Seattle and Portland, it says the distance is 2.74 minutes, which is absolutely right because I live in this region. And so what it's saying is in 1.5 hours, let's stop. And it's telling you where to stop. It tells you 108 Old Highway 603 Chehalis, and it usually gives a name as well. Yep, the name is a 76 station. And so if you actually go in here and go into maps.google.com, you can just make sure that this particular location is actually a rest stop. And so yeah, you can see here that it is a rest stop here. Again, it didn't find quite the right loves or whatever along the way. And so it may not, even though it gives a boost, the distance may not be the right distance for it to stop at someplace else. So we can do something longer as well. So we can go maybe Sacramento, California, and then do a test. So it's a long road trip. And here you'll stop at hotels and everything as well. But, this is going to assume that you're going to have a straight route going from point A to point B. Okay. And how long it's going to take. And depending on that, it comes up with output. So here you can see the first one is going to be a Love's Travel Stop. I have stopped here. It's one of the best travel stops. Okay. And then you keep going. And the next one that you're going to do is Fred Meyer Fuel Center, and then so on and so forth. Okay, so you can see here that it takes 11 hours if you 11 and a half hours if you go non-stop, and I believe it gives around 4 to 5 stops, which is exactly what we want. Okay, and like I said, this has 3099 ratings with a user rating of 4.2, so we take all of this into consideration as well. So with that, hopefully you're all excited for this application, everyone. So tomorrow I'm going to again create the API gateway, and I'm just going to deploy this code, do a little bit of front end on React, and deploy it on AWS Amplify, and we should have the web app ready to go. And the last thing I'm going to try and do is actually showcase this on a map, so that I'm trying to figure out how exactly is the best possible way, but I think I should be able to achieve that as well. So with that, have a good rest of your day, everyone, and I'll see you all in tomorrow's video. Bye bye.